Hello. Welcome, everyone. Thank you so much for joining us this morning. We are a very select group, and I hope this means we can really have a fruitful and deep discussion on this matter of, extreme importance. So the theme this morning is water, food, environment, nexus. And we have a very interesting range of speakers. We have two very expert young Chinese professors who will be sharing their expertise. And then we have expertise from the World Food Programme, giving us a global perspective with Martin with his very long background in climate issues as well. And Fred Duby, who has a long experience in China also, as well as international perspective, which is extremely valuable. So just to introduce myself briefly, my name's Joan Anderson, and I work in Japan. I work with the Soka Gakkai International, which is a Buddhist network that also is an NGO engaged in awareness raising and education. And we have a long history of cooperation and collaboration with the Club of Rome that goes back to the founding president, Aurelio Pecce, who had a dialogue with our president, late President Daisaku Ikeda. So I'm very honored to be able to be here today and continue in a small way this collaboration. So first, I was thinking we've been spending 3 days in a lovely hotel, but I think I have rarely in my life felt more remote from the real world. I think I've never been in one building for 3 days without going outside before. So I just thought it would be interesting to just ponder for a moment. While we're here, we've been drinking water, we've been eating lovely food, and maybe just to sort of try to think a little bit about the food and the water that we've been consuming while we've been here, and the journey that the water and the food have been on, and the people who've been involved in getting it to us, to sort of focus on this topic. So just for a few moments, let's try to imagine that. So I think there's a huge sense of appreciation that we feel when we do think of that. And food and water, for most of us, are things I think we often take for granted. So let's have this attitude of appreciation when we approach this topic. And I'm looking forward to a very rich exchange. So first, I would like to call our first keynote speaker, Professor Luo Yufeng. And he is, if I can just open my notebook at the right page, he is from Wuhan University. He is an expert on irrigation and drainage engineering and the impact of climate change on rice irrigation, which of course is a hugely important topic here in China. He is also the UNESCO chair on Asia-Pacific Water, Food, Environment Nexus, which makes him a perfect speaker to open this session. And he also has experience of studying in both Australia and Texas, interestingly enough. Professor Luo, thank you so much.
Okay, good morning, everyone. I'm from Wuhan University. We have a School of Water Resources and Hydropower Engineering. Yeah, okay. Yeah, it's okay. No, it's okay. Yeah. And I'm also co-chair holder of UNESCO chair Asia Pacific Water, Food, Environment Nexus at the Wuhan University. Okay. 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 Okay, thank you. Yeah. Okay, then first I would like to introduce our chair first, and then we go back to biodiversity. Okay. Okay, as we all know, water, food, environment are important resources and or factors to maintain sustainable development. And there's a complex relationship among food, water, and the environment, especially for Asia Pacific area, where extensive agriculture exhausted the water research and pollute the environment. In the context of global population growth, environmental degradation, and climate change, fresh water resources are increasingly scarce and the food supply is under pressure. This is our long-term objective, is to help achieve SDGs by strengthening the capacity of leaders and the practitioners in the application of the WFE nexus approach in order to achieve water and food security in a healthy environment. Yeah, okay, thank you. And these are the specific objectives through our research and to develop and establish and confirm new theories and methods for WFU nexus and the related issues within the Asia Pacific region, and also provide a variety of in-person and online multidisciplinary education opportunities, and also strength and sustain institutional capacities in the application of WFE nexus approach. And also develop publications, tours, websites, case studies that foster global knowledge and support integrated water resources management and food security. So in the face of increasing climate instability, demographic growth, and food demand, environment pressure, there's an urgent need to resolve the degradation of water resources and stop further decline in biodiversity. And the WFU nexus will hope to reduce the degradation of water resources and the water environment, and also stop further decline in biodiversity caused by agriculture-related activities. So here are some example of our activities. Here is an example of research. This is a project assessment of certain agricultural options in Asia and the Pacific, supported by the FAO of the United Nations. And also here are the training and the capacity building, two projects on this training and capacity building. And this is another example. And we also have some exchange. Here we organized international workshop on irrigated agricultural development for ecological sustainability in Henan River Basin, Mongolia. Maybe I will talk about this case, this story in our panel discussion. And here's another workshop we organized. Okay, then we go back to the sustaining biodiversity in water-saving irrigated rice fields. Okay, as we all know, rice is our most vital food source, feeding over 4 billion people, more than half of the world's population, and supporting 150 million farmers across 100 countries. As a major rice-growing country, China's rice industry occupies a pivot position in the world. In China, rice provides energy and nutrition for about 65% of the population. Yeah. And we all know agriculture is the world's largest consumer of fresh water. Yeah, in China, more than 60%. And nearly about 80% of the rice production is distributed in southern China, and where the amount of water for rice irrigation accounts for over 90% of the total amount of irrigation water. So in the last decades, we developed many kinds of water-saving technologies. Here are the examples. The first one is alternative waiting and drying. Actually, rice, traditionally, rice fields are keeping standing water depths. Yeah, in Chinese, we say 水稻. That is water rice. So in Chinese, in English, it's lowland rice. But we also have Arabic rice that is also highland rice. But usually rice is planted in a pond, is grown in a standing water environment. But now we have changed the idea. We can actually rice doesn't need so much water. We can keep the rice fields dry for a few days, 3 to 5 days, especially during the late stages. So we have AWD, alternative waiting and drying. It's also there are many research from the International Research Institute of Rice in the Philippines. And here is the second one is controlled irrigation. It's keep the rice field even drier. And then the third one is system of rice intensification. So we can even see the rice in the field. It's this kind of water-saving irrigation technology is from the Africa, Madagascar. It's very interesting. So traditionally, rice is grown in flooded fields, but now we changed to water-saving irrigation. There's low standing water for a few days, but we still need some water in the field. So these changes in water conditions of farmland lead to the changes in the field ecosystem. Because the water conditions changed, then the ecosystem also changed. And the rice paddies are artificial wetlands that supply people with food and provide wildlife with habitat, breeding areas, shelter, and feeding grounds and other services. And the rice fields take an important part in agricultural ecological system. Yeah. This is arthropods and weeds. We don't like this arthropods because there are some harmful insects, and weeds also take some nutrients from. But these are not so good. But we still need to keep them in the field. Actually, we have enough food, we have fresh water for drinking, but but rice field also cause some environment problem. As you may know, 18 years ago in Wuxi, in the Taihu Lake, there's algae bloom, very big problem. It cost about 2 million, impacted the tap water for about 2 million people in Wuxi city. So one of the reasons of the algae bloom is the pollution from rice field. We irrigate too much water to the rice field. Okay. And we also under too much fertilizers, and then it goes to the water bodies. Okay, now we conducted a research on how to sustaining the biodiversity in water-saving irrigation rice fields. This site is about 200 kilometers from here. It's not too far in Jiangsu province. We have two treatments, controlled irrigation and traditional flooded irrigation, and two replicates for treatments. And here, the sampling days, we sampling the weeds and insects. Okay. For the weed species, the density of weeds decreased about 38%, and the coverage decreased 14%, and height increased 39% under the controlled irrigation. And the weed species, for weed species, CI favored semi-aquatic weeds, and TI favored aquatic weeds. So CI effective suppresses the growth of dominated weeds in the rice field and reduced weed density. For weed diversity, the Shalom index decreased about 11.5% on the CI, and the evenness increased 3.2%. And the species composition, CI dominated by the Echino, Koala, Cruz, Gali. It's too long. Okay, I will go. So as for the arthropods community, specific on the traditional irrigation, the total number of arthro families and the species was higher than in CI. And for species richness compared to TI, the average proportion of the predatory regional enemy community in the CI was higher. So this is diversity and pest dynamics. So okay, last the conclusion. Here we still have some challenges. The controlled irrigation significantly conserve waters, but prolonged absence of standing water may simplify ecosystems and suppress aquatic diversity. So we may need to do some modification to the current water saving irrigation scheme. The first one is to maintain standing water during the key growth stages or after rainfall. And the second is using weather-based irrigation scheduling to enhance rainfall use. And the last one is integrating biodiversity indices into irrigation management. Okay, so the conclusion is that ecological informed irrigation ensures harmony among water, food, and biodiversity. Okay, thank you very much.
Thank you very much. That was very concrete and also hopeful, I feel. And of course, we'll have the chance to ask more questions later. So now our second keynote speaker is Professor Yingji Pan, and he is a professor at the Northeast Institute of Geography and Agroecology of the Chinese Academy of Sciences. And he has a PhD in ecology from Leiden University in the Netherlands. And his expertise is in the area of wetland plant ecology and ecological restoration. Thank you very much.
Thank you very much, Joanne, for the introduction. And please. I'm Yingji, and so today, I'm a wetland ecologist. So today I will give two case studies on bird conservation and as well as food security. So migratory birds I'm talking about. So in total, there are 9 flyways worldwide for the migratory birds. And one of them East Asian Australasian flyway. So this dark blue one. And so this is the largest one because it covers the largest number of countries and also suffering a lot from the habitat loss and under human disturbances. And you can see most of a large part of it Siberian area, so suffer from the climate change as well. So it covers most part of the Chinese coast wetlands. So today my case is along this flyway and in Yancheng City. There is a big national nature reserve for rare birds. So why Yancheng is important? Because firstly, it's international important wetlands by harboring over 400 bird species, about 29% of the national total. And it's also the key node of migratory flyways, and as a key breeding and stopover site on East Asian Australia's flyway. And also it has been recognized by UNESCO World Natural Heritage, designated as an international important wetlands by Ramsar Convention. And so it also provides key habitats. So today, the two cases is, the first case is in the core zone of this nature reserve. And the second one is outside but just nearby the nature reserve. So today, the first one, it's more about land sparing because it's in the core zone. And a brief history of this land. This land is about 13 square kilometers in total. And in 1997, it was firstly transformed into a fishery pond for the first time. And then in 2009, it has been included in the nature reserve. So the fishery ponds were returned back to wetlands. So in the next 10 years, it faces problem of dense red growth. Because if the red is too dense, it's really hard for water birds to active. And also the lack of water resources. So in the end of 2024, a systematic ecological habitat restoration project has been done there. And so since then, we did a lot of monitoring projects in this area. So firstly, I will talk a little bit, introduce the way of the restoration. So the zone A is especially for the waterfalls. So it's primarily open waters after the ecological restoration. And the zone B is mainly for small and medium-sized wading birds. And for zone C is for arboreal, like cormorants and herons. And number 4, zone D is specifically for the red-crowned cranes. So the optimal water depth was kept in between 0 to 30 centimeters. And the red-crowned crane is a very symbolic bird in Chinese culture because it represents longevity and health. And it's a very elegant bird, and it's a migratory bird. And the Yancheng is like a kind of southern wintering site for it. So we set up 20 infrared cameras in this region to monitoring the 4 zones. And so here I show some pictures. So in the daytime, we monitor those birds, not only for their species, but also we count the population size and their behaviors or activities. And in the nighttime, we still see them, but most of the time they are sleeping. So we also did an intensive field work, including on vegetations, and we also on insects and the frogs, and also the microbial diversity in the substrate. So what we do, we want to understand the whole food webs. So what kind of habitats their food web structures can support different bird species and their populations. And so this is a preliminary result. We have like different bird compositions in 4 zones, and also the plant diversities and bacterial diversity. Then I will go to the case 2. It's more about the land sharing. So it's a migratory bird-friendly rice project just outside that nature reserves. So the surrounding, you can see, is most of the surrounding areas are rice paddies, and it suffered from intensive chemical fertilizers and pesticides, and intensive human activities. You can see all those houses, constructions. So the migratory bird-friendly rice field project, we collaborate with nature reserves and the local communities to support this project to provide friendly habitats and supplementary food sources for those migratory birds. And so in the autumn, after rice harvest, stubble and grain were left, and water was stored to maintain an average water level of about 10 centimeters, especially for providing a shallow foraging space for migratory birds within carrying capacity of the rice paddy ecosystem, introduce basic organisms to build a complete food chain to attract migratory birds to rest and forage. So in this picture, you can see we have both red-crowned cranes and white-crowned cranes. They are foraging in these paddies after harvest. And also the model was a nature reserve plus farmers collaboration mode. So nature reserve provides technical and conceptual support and transform the planting methods, including reduced chemical inputs and winter fallowing. And there is also a compensation or subsidy to offset the losses caused by bird foraging. And local communities benefit from conservation and gaining through participation. And so from December 2024 to July 2025, a total of 26 species of fish, benthic, and aquatic insects, and 16 species of plants and 30 species of birds have been recorded, including rare birds such as red-crowned cranes and white-crowned cranes. Here is another picture showing the white-crowned cranes. And also the birds here, they also reproduce their offsprings, including this black-winged stilt and the little grebe. You can see they're nesting and they are doing egg incubation. And we also did a lot of research in these rice paddies, including the high-spectrum drones and also the eDNA technology to understand also the food webs in this area, and infrared cameras to monitor the bird diversity here as well. So as a conclusion here today, I show you 2 examples. The first one was in the core zone of natural reserves, and there was a former fishery pond. And because I would like to draw back to our session topic, the water food environment. So the first case is kind of we sacrifice food, like fishery ponds, to land, to birds, to conservations. And for the second example I just showed, it's kind of a harmony connections between human and birds. So here, I wouldn't like to say which way is better. I think both ways have their advantages, because in the first case, bird diversity is much higher than the second one. But the second one is still like a supplementary habitat and food sources for those migratory So I think the conflicts between man and birds will last forever, but we can try to reconcile them. So just like the conference scene, through those plural ways, maybe we can find some better solutions. So I would like to thank my research team, postdoc, PhD, and master students, and also those funding support. So that's all. Thank you very much.
Thank you very much. Another very inspiring case study, and of course of particular interest because red-crowned cranes are extremely meaningful and popular in Japanese culture too, and a symbol of exchange and cooperation actually in recent years. So now our next speaker, we're very honored to have Martin Frick, who is the director of the WFP Global Office in Germany, has been in that position since 2021. Previously, he led the UN Secretary General's Food Systems Summit in 2021. He was Senior Director of UNFCCC from 2017 to 21 and oversaw implementation of the Paris Agreement. He also built up the UN Sustainability Hub in Bonn and was involved in the UN Global Humanitarian Forum and involved in the establishment of the UN Human Rights Council and. I could go on for a very long time, but I'm looking forward to hearing from Martin. So thank you very much, Martin.
Thank you, Joe. And it sounds like nobody can work with me for a long time if you quote my CV here. I would like to focus briefly on two things that kept me busy over the recent years. And you mentioned the UN Secretary's Food Systems Summit. That was a process over 2 years, 2019 to 2021. And the key word, and that very much resonates, of course, with the Club of Rome, is the word of system. Because if you look at food as a system, you're getting answers to some of the most pressing questions of this world. And it's astonishing that we haven't done it for a long time. You mentioned that I worked with UNFCCC, the UN Climate Convention, and the biggest contributor to greenhouse gas emissions is by far our food systems, with way more than a third of the contributions, and yet for almost 25 years, we didn't speak about agriculture in the climate negotiations, just by virtue of it being considered to be too complicated. And climate is but one example. You mentioned before that agriculture is the biggest consumer of fresh water. After working for 2 years in the Food Systems Summit, I had a simple formula. I said, food is the biggest everything. Whatever you look at, it's the biggest source of deforestation. and I want to focus on that. It is also the sector where the poorest people of this planet work. The worst jobs on this planet are in food systems. Whether you are a harvest helper, a fruit picker, whether you're in a restaurant washing dishes, this is where the world's poorest people are. And I want to focus a little bit on the world's poorest people because this is obviously my day job now with the World Food Programme, the biggest humanitarian organization on this planet focusing on food. Now, let me give you a couple of shocking numbers. And I'm starting with a success story. When FAO was founded in 1945, the devastations of the Second World War also meant that hundreds of millions of people were hungry. And ever since, we had an unprecedented success story in reducing hunger in absolute numbers, while the Earth population went dramatically up. I believe when I was born in 1965, I'm disclosing my age, there were something more like 3 billion people on the planet. We have way exceeded 8 billion. And yet, for the most time of this development, the number of hungry people in absolute terms, not in percentage, in absolute terms, were going down. And that was basically the case until 2015, which was pretty much the reason why world leaders were optimistic and confident enough to define SDG 2 as not saying we are going to reduce hunger, but actually to say we are going to eliminate hunger, a situation we have never seen in the world before, that people feel so confident that you can eliminate hunger. And then somehow we took the wrong turn. And let me speak about that. about that time when the food system started, that was just before COVID hit. We had before COVID, late 2019, about 135 million people on the planet that were so desperately poor that they needed food aid in order to survive. Today, this number is 320 million. We have almost tripled the number of food insecure people. Now, there were geopolitical developments. There was COVID, of course, with a massive disruption. The war in Ukraine has caused, at least temporarily, the 5th largest grain producer of the planet to go offline. And that has sent shockwaves to the global system, where the commodity prices, in particular for wheat and for corn, are still about 20% higher than they were before COVID. And that shows a vulnerability that we didn't speak about. And I love speaking about the things that we don't speak about. One of the basic development patterns that were promoted by the World Bank and IMF and others were basically in a classical economic model to tell countries, you should be focusing on what your comparative advantage is and don't worry about other things that you can import cheaply. So if you're Kenya, you're very good in producing flowers. If you give your partner a Valentine on 14th of February in Europe, odds are that the flowers are coming from Kenya. Cotton, cacao, coffee, you name it, all of these commodities coming on the world market. And the theory is that in return, you are buying cheaply grain from Russia, from Ukraine, from Australia, the United States, the big producers. Now, this has become loop-sided. And so we have an affordability problem of food worldwide. And that brings me to a second assumption that I am not getting tired to challenge. Often in agricultural conferences or conferences looking after food, the narrative is we are 8.2 billion people today. We will go up to about 9.5. How on earth can we feed these people? The answer must be to ramp up production no matter what. That is wrong. We have enough food today to feed 10 billion people, but we have a huge problem of distribution, affordability, of waste, which is not only rich country wasting food by simply not consuming what they have at their disposal, but it's also poor countries wasting their harvests to a staggering amount, up to 40%, because technology is missing to transport the food, to cool it, to process it, to dry it, to put it in cans, etc. So if we are now zooming into some of the world's poorest countries, let's say landlocked, least developed countries in Africa, you have a situation in which the food import becomes unaffordable and people who are living, let's say, on a government payroll, doctors, nurses, teachers, simply cannot afford the food anymore. And this is what I want to briefly say. Our idea of a distributed global food production has many advantages, and I'm certainly not anti-trade. For many countries to become autark from the global market is simply impossible. But the considerations that A, you become vulnerable by depending too much on the world market, and B, you need to provide jobs for the poorest people in your country, point to more local food production. And now it's exactly there where there is a tremendous opportunity. UNCCD, that's the Convention to Combat Desertification, estimates that 40 to 60% of the world's arable land is moderately to severely degraded. So we lost arable land at an unbelievable scale, and we mostly did so in dry lands. And that's the piece of hope which I will give you in 2 minutes, that this situation of land degradation is reversible. And it's reversible actually by low-tech measures. What we are doing as the World Food Programme is in Sahelian countries to revitalize technologies that were known in classic times 2,000 years ago. micro dams that look like half moons, that hold the rainfall back, that enable trees to grow. Once you have a little bit of tree cover, surface temperature on the soil is going down by 4 to 6 degrees, humidity is going up, and you have the possibility with agroforestry system to start growing food again where there was no food available before. Now, the people we are working with are, in the closest sense of the word, dirt poor. They have nothing but this dirt. Irrigation is unavailable. Hybrid seeds unavailable. But we can do that with indigenous technology and also using digital devices, for example, to provide granular weather forecast. And while I'm emphasizing on that, and I want to conclude with that, is what they are doing is restoring ecosystems that have been working for a very long time. They're building their own food security. They're bringing back biodiversity. It's providing jobs mostly for women, because in the rural areas, you have the women left when the men are migrating to the capital cities, and they are sequestering carbon on a massive scale. So if you put all of these pieces of the puzzle together, there is a fascinating different perspective to the bottom billion on this world, that these poor farmers actually can be our heroes, saving the world by getting the carbon back in the soil, getting ecosystems working. And so if we change this perspective, if we are maybe even prepared to pay these farmers to restore their own land, to stand on their own 2 feet again, we also have a global solution. Thank you.
Thank you, Martin. You've covered a wonderful amount of ground in your allocated time. That was fantastic. I think you've given us a lot of food for thought and many, many different avenues to explore. And just to explain, I'm going to take questions at the end when everyone's here in the panel. We've already received one question online. So now our final speaker is Fred Duby, who has a long, long history of working in China, actually, as well as many other countries. He's a professor at the Beijing Genomics Institute and has been centrally involved in the development of that institution. And he's a member of the World Academy of Arts and Sciences and was a senior advisor to the UN Global Compact. So he has a lot of experience of seeing how business can contribute to improving the world, and particularly we'll be talking now about, I believe, some examples from China and maybe from Africa as well today. Thank you so much, Fred.
Thanks. I don't know if I need the microphone, but we'll see what we can do. I have a very bad memory, so I have my crib notes here so I can remember things, but I don't have my glasses, so I can't read, so that's okay. A little bit about me. I'm, first of all, an apprentice bridge builder. I've been trying to build bridges between people, between countries, between continents for a long, long time, and I'm still learning, and I've got a lot to learn. Fortunately, the Club of Rome is a great place to learn how to be a bridge builder. I'm also an observer. I look at things and I try to understand what's happening and why it's happening. And I try to have lots of friends. And I heard that yesterday. I think the great thing is China wants to make friends. It doesn't want to make enemies. And I think that's very, very important that we are in our frame of mind, that we are out to make friends, to collaborate with people. I start a little bit talking about the opening. I'm here today because of a man called Deng Xiaoping who opened China. And BGI is here, and I wear proudly the shirt because BGI is a product of the opening. 4 guys went to universities around the world, became very famous, became very well educated, and then said, okay, we have to contribute to the world, and were part of the Human Genome Project. And that was really the start. And at that time, BGI had 47 people, and we owed $10,000. We now have about 8,000 researchers, and we probably owe a lot more than 10,000. BGI is an NGO, a true NGO, and it's a true not-for-profit NGO. We have a strange thing, though. We have some divisions that make money, and the money that they make is reinvested in our research, in our young people, in our education. So that's BGI. I want to shift now to 2022, the COP15, biodiversity. And I was there representing both BGI and a foundation, a Chinese foundation called the China Biodiversity and Green Development Foundation. And we do a lot with birds. And I met a young man, and it was very interesting because he had a goal, and his goal was to change all the soil in Africa. And that is an amazing goal for anybody to have. And it's even more amazing when you find out that he comes from a country called Gambia, the Gambia. And if you don't know the Gambia, it has less than 3 million people. It's one of the poorest countries in the world. And his idea was how to motivate, how to aid the farmers in Gambia to take care of their soil. And that was such an interesting thing that we got together, and I've been looking at this. And what I've learned from my days in China is you can't help people, but you can give people a hand. And you have to give them the hand that they need, that they want. You can't do the development for them. You cannot develop another person. You can try with your wife or your husband. It doesn't work. But the thing that we saw is that the Gambia has an approach, and the approach is a very interesting one. There are two pillars to that approach. And the approach is high-level science. And the Gambia is looking forward, and why I'm here today is also to recruit experts, to recruit people who can give a hand up. And the first thing is, we know that we need to have control of the quality of the soil. And that control has to be almost real time. And it's quite inexpensive to do if you do it properly. If you use a cell phone and you use a thermometer, you can do a lot of things. The other thing is that we have to find ways to develop teams, people, communities that will take care of this, that will do it. And so we have the Gambians came up with two ideas. One is called the Soil Information System. There is a big one in Africa, but there is one in the Gambia which is working very, very well, very inexpensive, very people involved. And something called the Soil Doctors Program, where young and old Gambians, farmers, I should mention to you that Gambia's main, let's say, employment are sustenance farmers. Very, very small, all very, very small, all very poor. As I said, it's one of the poorest countries in the world. But they have their soil, but they've also degraded their soil over the centuries. And they're helped by the pharmaceutical companies who supply greater and greater quantities because every year you need more. So the question is, how do we change that? And we change that by ensuring that people understand the value of the soil that they have and that they take care of it. So one is to have information. The second thing is to have technology. And one of the things that was discovered, Gambians like oysters. There's a small coast line of Gambia, about 80 kilometers, and a great pile of oysters. And somebody noticed this and said, what can you do with oyster shells? And it turns out that you can grind them up, and they are really a great additive to the soil. So little things like this are happening. The other thing is Gambia has what they call rainfall agriculture, but it also has a river, and that river is very saline. And depending on the storms and so on, most of the water is salty. So we need new crops that are designed to withstand or to live or to thrive in salt. And that's where sort of some of BGI's technology can come in to be of help. We need plants, first of all, that people like to eat, because it's no good to plant stuff that nobody will eat, that are nutritious, and that help the soil. There's a project you probably know of called the Orphans Seed Project, the Orphan Crop Project, where BGI and a number of other organizations in the world, I don't think, the FAO is one, but I don't think the food program is in that. We're developing seeds, especially for the 156 crops that are the most eaten in Africa. And it's working. We're getting better and better crops, better and better seeds, and it's something that everybody can afford. So the program in the Gambia has taken root. Every day, people come from different countries in Africa to see what Gambia is doing, to learn, because what the Gambians say is, if it works for us, we want to share it with everybody. We know that they will not imitate us, as China has not tried to imitate others, but to take the ideas and then nationalize them, if you want, make them valuable in their own area, and then go forward. So it's a very, very exciting project. And some of the people that are here, certainly the AAIB is one of our great friends, because I think that is an organization where giving a hand is one of the key goals. And so I think I will end here, and we'll have more time for discussion. So I add 2 more minutes to the discussion time. Okay, thank you very much. Okay.
Thank you very much. So if everyone would now like to come to the front, please, to join the discussion. Thank you. So thank you for your very thought-provoking and varied presentations. And I would like to, I'll start with one question which we have received online from Anitra Thorhaug, is it? Yeah, who I believe is an American, a member of the Club of Rome in the US, is that right? And her question is to Professor Luo. It's what is the effect of diverting water for rice field, diverting water from natural ecosystems for rice cultivation? Do you understand the question? Maybe, can you? So the effect of all this water being used for rice, irrigating rice fields, what is the effect on, I guess, the ecosystems and the groundwater in China? It's a very big question. So please, if you have either of you, I think the question was perhaps directed to you, I think. Okay. Thank you.
Okay, thank you. All the water for irrigation.
So it's a question about what is the effect of so much water being diverted to rice cultivation from natural?
Yeah, actually we use too much water for rice. As you know, most of rice is grow in southern China. In southern China, we have so much of rainfall, too much rainfall, and too much water stored in reservoirs, and in the rivers. There's always water. So actually, in the southern China, we don't. We really have enough water, and the farmers also use too much water for irrigation. It caused a big problem. The first one is the long point pollution. You know, we have to keep the yield high. Then we use too much fertilizers and also herbicides, pesticides, and other agricultural chemicals. So the use efficiency is quite low. Most of the fertilizers flow down to the water body, to the rivers and downstream water bodies. It causes eutrophication. And the Taihu algae bloom problem is also partly caused by the long-point source pollution. So this is one environment problem. And the other one is greenhouses gas emission. You know, there's so much methane and emitted from rice fields. It also cost of the standing water in rice fields. So from our many studies, if we reduce irrigation water, so the methane emission will be reduced. So in the last about 3 decades, we tried to disseminate water-saving irrigation for rice, even in southern China. Even we have so much water in this area. So,
Thank you.
Yeah, okay.
Thank you very much. Thank you. I'm not sure if there were other questions from online. Maybe not. Oh, there were? Yeah, thank you. Thank you. Oops. Yeah. Okay, great. This would be a question for you, Professor Pan. Is there restoration done in migratory bird pathways, the naturally occurring species, which would be found in a comparable ecological wetland? And this is also a question from Anitra, who is contributing greatly with these questions. So yes, is this restoration being done to bring back naturally occurring species which would be found in a comparable ecological wetland? Thank you.
Yes, thanks for the question. My answer is yes, because we do those restoration projects, and we just say those attract those birds to come. It's a good shelter. So normally it's less impacted by human, especially in the nature reserve. It's a kind of, especially in core zones. So no tourists can enter, and only the staff can enter. So it's a very low human impact. So all those nature rare birds comes and attracted to that area. Yeah.
Thank you very much.
So it's kind of the most a very hot spot for diverse bird species. Yeah.
Wonderful. So I have a question which I'd like to put, I think, to all our speakers, but perhaps starting with Martin and Fred, which is that we often are hearing these very encouraging examples which happen perhaps on quite a limited scale with quite a high level of input for encouraging people to do more regenerative practices consider soil health, bring back maybe traditional knowledge and practices. But these often are happening in quite small areas and, as I say, with quite a lot of input, and over, obviously the time involved in developing these is quite long often. Do you see these practices as being ones that can be scaled up enough and quickly enough? That's the question that always seems to come to me. Thank you very much.
Well, I think what's happening silently, but it's becoming bigger and bigger, is a completely different understanding of how food is actually growing. I dare say that we had a big success story with industrial agriculture, and I'm not talking that down. You know, I mentioned the numbers going down over the decades after the war, which was the Green Revolution, which was fertilizer and pesticides. But we now understand the environmental price, the pollution of the water, the loss of biodiversity, all of that. And we understand with much higher precision what actually makes our plants grow. You know, we had such a simplistic view that soil is something that ensures that your plant is not tipping over, and if you pour enough fertilizer on it, then everything is fine. We have learned complexities that are mind-blowing with mycelial network and fungi, and all of these interactions that you have in the soil is really latest science. And there is something really exciting going on, which on the one side we understand better what actually is food production, how that works, and we rediscover indigenous knowledge where sometimes people, of course, didn't have the microscopes and what have you, but they had an understanding, you know, like crop rotation, having nitrogen fixes, improving your soil by doing that. So I'm absolutely convinced, yes, we can scale up. We have to scale up because the environmental costs are way too high. We have to bring natural systems back in balance, and that always means restoring the cycles that were there and functioning. And if you look at, you know, what is our environmental crisis, it's all these cycles that normally are genius engines to keep us alive, which are out of whack. The nitrogen cycle, the carbon cycle, where we are just blowing too much in the atmosphere. And, you know, 2 days ago, we had this professor who caused a bit of a stir saying, CO2 is not bad and carbon is not bad. Well, of course it is not bad. I am carbon. What we eat is carbon. The question is, can we get it back into a cycle that is closed and where the output of one side is the input on the other side, as nature has been doing for billions of years?
Okay, thanks. I guess I'd like to tell you another anecdote. I mentioned that Deng Xiaoping sent a number of young Chinese abroad to get a doctorate, basically, at some of the world's best universities. And one of the people came back. He was here at this meeting up until yesterday, Zhou Jinfeng. He's a former council member of the Club of Rome, 2 terms. That's the maximum you can have. And he and 9 of his friends who had come back, returned to China, decided they need to do something to make China a better country. And they came up with the project idea, which was called the Glory Project. And they said the glory of China would be when every Chinese person had access to a dignified, sustainable employment. And that was a big problem, not so much in the south of China, in the rich parts of China, and we're talking now about the turn of the century, but primarily in the hinterland, if you like. And the idea was that these 10 people were going to make a fortune because they had a very good education, they had good ideas, One was they had the first internet service center in thing. The other one had the control of the medical supply business. So they took this and they brought this and said, well, how could we bring this into the northern parts or the poorest parts of China? They made a couple of mistakes, but then they learned something very interesting, that they could impact agriculture in a very, very powerful way. And one of the people who was very interesting, he used to sell watches from the handlebar of his bicycle at the university where he was teaching, but to make a little extra money. And he realized that China was becoming wealthier, and that meant that Chinese would like to have more meat. And meat in China is pork. The only problem is that the pork was terrible. And if you, I'm sure, well, you're too young to have eaten it, but the pork ate garbage and was in bread. And so he went to different universities and said, develop for me pork food. Tell me what the recipe is. And then he went out and recruited about 30,000 farmers to grow the proper food. Then he went to another university, or actually 2 or 3 universities, and said, please help breed proper pigs. And all of a sudden, the whole pig or pork industry in China was born. It was ecologically sound, it was humane, and it provided a lot of employment and a lot of food for China at a really interesting price. And that sort of thing is, I think, the way you scale up. When you meet a need in a let's say, ethical, constructive way. And I think this is what we are learning. It has to be an ethically proper way. It has to look at the good of the people and not look for profits at the. So I think that helpful answers your question, part of your question.
Thank you. Do you have some comment on this topic? Yeah. Would you like to comment on?
A little bit, because I'm thinking about the wetlands, and so wetlands can always serve as we call it the ecological barrier between humans and nature. So just maybe add up to the question to Professor Low. So the wetlands, on the one hand, if in the dry season, the wetlands can offer some water supplement to the rice paddies, and also in the flooding season. So it's a big problem because we all drain the water, the extra floodings from the rice paddies. So if there's no wetlands, we just direct it to nature land and cause flooding problems to nature. But if there's wetlands, so still can mitigate the flooding, not directly to the nature. So besides those positive services, including the habitat for birds and pollution mitigations, but also for flooding or drought problems, it's still a very strong barriers. Yeah.
Thank you. Thank you. Are there, yes, please, if we have a question from the audience. Thank you.
Good morning. Thank you so much. This has been a very, very fascinating and deeply insightful panel and set of speakers. My name is Callum Douglas. I work as an independent nature and climate advisor based in Beijing for the last 20 years, and also as a consultant for the Asian Infrastructure Investment Bank, as Fred has mentioned. Now, there I'm very lucky to work with the chief economist, Eric Bergloff, who has put forward a very strong nature as infrastructure thesis, where we really see nature as the infrastructure of life. And a lot of what has been discussed on this panel has been very in line with that. I think if we see wetlands, for example, starting as this incredible infrastructure, which provides infrastructure-grade services for people and for the environment around as well, which is an important shift, I think, in thinking, because when we understand infrastructure very well, both from a planning and financing perspective, and we can apply those very well-known systems that we have to nature, financing and conservation, we actually already have the tools and the financing mechanisms that we can help to achieve the scale, which was going to be my question, but was your question at the beginning. I just wanted to thank also for the very beautiful regenerative agriculture examples that you gave in Indigenous learning as well, because in many ways that links very much back to the nature's infrastructure concepts, because once you have systems working ecologically in a way that they produce the services that they are intended to produce, which yes, humans can benefit from as well, then we really reinforce that for the benefit of all. And you gave amazing core benefits that come alongside that as well. I think the interesting thing is also when we take it up a level to think of this as a systems overall, and we see how they all really link together. And then you started to get to this also in your last comments. But when we see regenerative farms, for example, I think I'll give one example. In the terrible floods in Spain we saw last year, there was a video that was shown of two farms that were actually side by side, and the runoff from both of these during that time. And there was one from an agricultural, large-scale industrial farm where the runoff was brown and thick and very, very fast. And literally next door there was a regenerative farm where, because the soil had been left healthy and intact, the water runoff was actually clear. So then we get to the point, well, this is also massively affecting potential for flood damage control down the line and the billions of dollars of cost that come from that. So I guess my question was going to be on scale, but in terms of this, I just wanted to raise it up to think of how we can think of this as all these systems coming together, and the three that we talk about here are a perfect example, and then how we finance this going forwards. So perhaps not so much of a question as a comment, but if you have answers, please. Thank you.
Thank you. A very brief comment. I think quite often the magic is happening if you don't look at a single outcome, but you look at the systemic contribution of what that piece is doing. I have a wonderful example from Austria, mountainous country, and the Austrian railway system had more and more problems with landslides. So they were implementing engineering solutions, walls, and all kind of situation, and it was never enough. And at one point they understood that more and more mountain farmers went out of business because it was not lucrative anymore to have the sheep and the cows grazing the slopes. And they just gave them a bit of additional money, so they kept doing what they were doing, and that was stabilizing the soils, which in return is stabilizing the infrastructure. So we have to widen our view, and I want to say this comment to Professor Pan, because what I have seen in your presentation is beauty, so much beauty, and I envy you for your job. And in these calculations that we are having, beauty and the beauty of our landscapes, our cultural heritage should be a part.
Thank you. Does anyone else want to comment on this question?
Maybe I have a brief comment. So because I do study ecology, so in ecology we always think of complex systems, including complex components, including our human beings and also the wildlife. So it's really magic and marvelous to explore all those interactions and yeah. So you talk about the different systems. We have different ecosystems, and we also have social culture systems, and how different culture and ecosystem reconcile to each other. And I think that's also our aims to or persuade. Yeah, thank you.
Thank you. Yes, I believe we have.
Yeah, thank you very much to all the four speakers. Fascinating talks. I have 2 pages of notes over here to digest everything. And it has, I agree with the basic premise that we are looking at a very complex ecosystem. It's not only an ecosystem, it's also a social and an aesthetic and an ethical system that needs to be transformed. And that regenerativity as a phenomenon is something that could apply and improve performance, can be scaled, can be financed, we have the tools, etc. So very positive message. I'm very thankful for it. But it is making me question this notion of regenerativity that seems to underlie this. We think that regenerativity is about holding the environment in some kind of a safe, managing the environment safely without changing human beings. And I'm wondering why we still continue to eat rice when there are also a lot of pests that are produced. Why can't we eat the pest instead of the rice and try to protect the rice and keep growing the rice? Because we have pulled ourselves out of the ecosystem, and our view of regenerativity, whether it's with regard to soil or with regard to water or agriculture. So somehow, I'd like you all four of you to try to push the boundaries of this notion of regenerativity so that we are not standing outside the ecosystem and trying to make it more efficient and more complete and more whole, but include us into it.
Wow, that's a fantastic question. Okay, Fred.
Yeah, I'm not quite sure I understood your question completely, but
I'm not sure of that myself.
oh, okay, right, good. I'd like to share another anecdote, because I live with anecdotes. There's a professor, Zhao Jihai, who has spent the last 40 years of his life as the father of millet. Millet is a very, very old crop, and it sort of fell out of favor maybe 2,000 years ago. It's about 7,000 years old, 2,000 years ago. And it's now, he sees a tremendous value in it. Millet is interesting because it has all the nutrition that women need to successfully carry a child. It has almost all the protein of wheat. It is very, very productive. It's one of the best plants in terms of production per square meter, if you want, but people don't like it. And what we've found is that if you mix millet and rice, you have the best of both worlds. So that kind of change, and now millet has become really a very standard part of almost all diets in China. And you can tell it because the rice is white and the millet is slightly golden, and it does. So we have to look this way, how we can bring about products that serve nature and serve people. And I think that is part of the job of science. It's part of the job of you as consumers, me as a consumer, also to look more deeply into what we need in terms of nutrition and not be so wasteful.
Try to answer Paul's question on regenerative. I mean, for me, regenerative is largely, in environmental terms, simply repairing the mistakes of the past. And I think the biggest job engine in the 21st century might be repairing the damage of the 20th century. So that is big, but it also means to look at things in broader terms. You just made a wonderful example with millet. We used to have on the American market before the First World War about 125 varieties of apples. Today we have 6 varieties and they are pretty much staple all over the planet. And because people want to have them, they are produced with an enormous amount of pesticides and fertilizer, and they look like a fairy tale apple, but I wouldn't eat it, right? And then if we are looking at ourselves, you are immediately coming to cultural traditions. We have been reduced in a way that 60% of our calories that we consume come from 4 crops. It's rice, wheat, corn, and soy. That's it. That is not normal. If you would have traveled 100 years ago, that would have changed from region to region. There is at least 7,000 different species we know of are edible, In reality, it must be much, much more. And often, this regenerative also means broadening the horizon, going back to traditional crops. And you see that young farmers are reactivating traditional varieties. They come with a specific recipe. The recipe might be something that is indigenous and it's special for a certain celebration. So there's a whole ecosystem outside that ecosystem.
It's for the people online.
Oh, yeah, people are online. So the question of scaling, perhaps we have it backward. Rather than thinking about scaling to grow more in quantity of 1 or 2 or 4 crops, we should be thinking about what's a strategy for descaling back to 7,000 crops, but in smaller quantities.
Yeah. If I may answer, and you, Fred, you just mentioned one of the key words, which is nutrition. In our oversimplistic view of food, we were basically just counting calories. And what we have is malnutrition, and we have obesity as a global pandemic. And of course, many of the organically produced food, of the rarer varieties, are more expensive than what you would pay for industrial produced rice. But if you do a full cost calculation on the social, the environmental, the health costs of it, they will be the better choice. So it's a whole rethinking of that. And for me, food waste is one of the key examples, because nobody has a benefit if you buy in abundance and then you throw away a third of your food.
I'd like to just add the thing. Before I came here, I was in Haikou at the 5th World Forum on Ceology. Now, I don't know if anybody here knows what ceology means. I didn't until I went there. It's a Chinese derivative, which is an action word. It's a verb, not really a noun. And it describes the full food system. And let's say from seed to toilet, okay? and to toilet is very important because we flush down the grain so much value and don't think about it. But it's interesting, this has now become a very powerful institute at Renmin University. And it's really, and it has adherents from all over the world who are now trying to find out how do you improve the food system. And again, from seed to toilet. And it depends also on each individual, how you see your role as an eater. You know, and it's the first time I've seen that written down, your role as an eater. Okay, and you have a very important role to play, because if you don't play it, you're dead. Okay.
Fantastic. So I think we are sadly approaching the final part of this discussion. And it's been extremely exciting. And I think for me, even preparing for this session has been very important, because as you've been saying, each of us in our daily lives is intimately connected with food. And this issue has so many ramifications for all of us in terms of what we choose to eat, what we choose not to eat sometimes, and how I even grow some of my own food on my balcony in Tokyo, and I'm wondering who's been watering it while I'm away. But this issue is one that we can all benefit from thinking more about. And I have a final question, which is that I feel these examples of regenerative approaches are not just good for soil, good for addressing climate change through sequestering carbon, through bringing back traditional practices, but they make people feel good about themselves and their lives and their contribution. And I feel we need to find ways to communicate this better. And so I have my final question to each of you is, do you have some ideas about how we can communicate these new ideas and approaches better? Thank you. Please.
First, okay, thank you for your question. I think actually this platform, like the conference, is a good chance to communicate for the people from different disciplinaries. And yeah, and also for Paul's question, I think you're actually asking about the boundaries between nature and humans. Maybe the case I showed, land sparing and sharing, is kind of two extremes. So one, and even there's more extremes that like a human take over everything and exclude nature and all the wildlife. So I think there is actually no clear boundaries, and we're still figuring out where is the boundary. But yeah, from land sparing, we just leave the place for the nature, but exclude the humans, or we exclude nature and just for humans. So our ecologists, we are trying to figure out, and also for Column's question that finance people. So we communicate well because our ecologists can provide evidence and data. So for your decision making, for evidence-based or nature-informed finance. So I think it's really important to communicate between our peoples. Yeah, thank you.
I think communication is really important. Do we say that we Chinese eat too much pork? We we eat too much rice. But I think it's a tradition. Yeah, it's a tradition. We need to understand our tradition, and communication is important. And I think as for the tradition, maybe there will be some change in the future generations because it's changed. The environment, the society is also changing. Maybe we may change our diet, and okay, I have told the story. I think Mongolia people should change their dietary urgently because we have the dust storm. Maybe 20 years ago, the dust storm from Inner Mongolia, but now no dust from Inner Mongolia. Now it's from Mongolia. Mongolian people grow too many sheep and cattle. 70 million cattle and sheep grown, but they have only 3.5 million people. Everyone has 20 sheep and cattle. Overgrazing caused big problem. Pasture degradation, desertification. Yeah, it's a big. So I think we may develop irrigation system in Holland River basin and grow wheat or maize and reduce the amount of cattle and sheep. But it's also we need to communicate. Yeah.
Thank you.
It's difficult to change. So.
Thank you.
I have a suggestion, really, and it's a question to myself. What am I doing to improve education of young people? And I think if we can answer that question, what am I doing? What could I do? What should I do? How could I do it? I think we would bring about a tremendous change. And I think this is one of the difficulties. We have turned education into a platform for jobs. It's a platform to satisfy the Industrial Revolution. It's not a platform to help develop people, help people have a healthy, good, happy lifestyle. And I think that is the key thing, and if we don't do it, much of what else we do doesn't count. And if you work in a kindergarten, if you go to a grade school, you go to a high school and talk to the young people and see what they need in terms of information, in terms of training, in terms of thought, provocation, to have a good, sound life, then you can start making changes. If we don't do that, we're lost.
It's almost what I wanted to say. And I can...
I wanted to be last.
I can just say, and I think key is the appreciation of food, to celebrate food, not to eat alone, because eating alone is just a very sad thing. And the more people you are sharing your meal with, the less food you are wasting, the more you are actually celebrating what you're having. And educating kids is as simple as teaching them how to cook with raw materials and not have prepared meals, not have ultra-processed food, because it's not that complicated to boil a potato or to do scrambled eggs. You know, you can do that, and that relationship to the food, that starts very early if we get it right.
I just wanted to make a snide comment. In Bali, you don't eat with anybody. It's something that you eat, do by yourself. In the morning, the cook in the family, your mother, makes a big pot, and during the day, people come and eat, but they always eat individually. Okay?
At least they cook together.
No, one person cooks, but so I think I don't know where that culture comes from, why it's there, but the last time it was in Bali was about 15 years ago, and it was still highly respected.
There must have been some family manners with very bad eating habits.
Thank you. Well, that's an interesting note to finish on. But I'd like to thank all of our speakers for very, very thought-provoking, thank you, very thought-provoking presentations. I'm sorry there was one more question from online that we couldn't get to, and maybe other questions amongst the group. But I think it was an extremely rewarding and thought-provoking discussion. And I, for one, would have loved to have a whole day to discuss this topic, because there are so many different aspects to it. But I think you've given us some very important information, some very important ideas, and as sorry to finish on food for thought, but there we are. And just like to thank everyone for your input. Thank you. And then we have the chance to eat together at lunchtime. So let's make sure we talk and enjoy that. Thank you.
Mr. Co-President.